In this video on PSAT SAT prep, we're going to look at some of the major differences between linear and exponential functions. Okay, it was tough to find a question that looked similar to the one that you had on your Google form, and so what I've done is I've set up two tables here that are similar to the tables that you had in your question to illustrate the differences between linear and exponential functions. And so what I know about linear functions is that they have constant rates of change. And so what that means is that if you increase the x, which in this case we're considering the years worked to be our x and the salary to be our y, if you increase x by the same amount, the y value is going to change by the same amount each time. And so if we take a look at this first table and just see if there is a constant rate of change, then from this salary to this salary, if we were to subtract those, we would see that we would have a change of $2,800. Then if we went from year one to year two, we would see that we had the exact same $2,800. If you just subtracted $61,600 minus $58,800, you would see that it was $2,800. And you would see the exact same thing for all of these values in this table. And so because there is a constant rate of change for this first table, we say that that function is represented by a linear function because it has a constant rate of change. Now, not every function has a constant rate of change, and so therefore not every function is linear. And so let's take a look at this second table and first of all determine, does it have a constant rate of change? And if it does, then it is a linear function. But if it doesn't, then it might be some other type of function that follows a different methodology for its rate of change. And so if you look here from 56,000 to 58,800, you see that you do have that difference of 2,800. But if you go for the next one, this is not a change of 2,800. And so therefore, this is not a linear function because you don't have a constant rate of change. And so what I'm going to do is I'm going to erase this and we're going to try to see if there's something else. Now, for exponential functions, the rate of change is determined by multiplying by the same number every time. And so therefore, if we try to, let's say, divide 58,800 by the y value before it, 56,000, what you would end up there is 1.05. Well, if you did that again for the values in this little sub-interval here, then you would do 61,470 divided by 58,800, and what you would find out is that you would again get 1.05. And so what we call this is a common ratio between these y values. And so whenever you have a common ratio where the rate of change just depends on a common ratio, we say that the function is exponential. And we can actually be a little bit more specific here because we can say that this is an exponential function with a rate of change of 5%. And the way that we know that it's 5% is by looking at the decimal here on this common ratio. And if we changed 0.05 to a percentage, that would just mean moving the decimal place 2 places to the right. And so that would be a rate of increase of 5%. And so in this second table, you're not getting that linear increase where it's increasing each year by the same amount, but you're getting a percentage increase of 5% each year, which basically just means that you take whatever the value is currently and multiply it by 0.05 and add it to the original salary to get your next salary. And another way to think of that is to multiply the current salary by 1.05 in order to get the next salary. And so this is exponential, where we have a percentage increase. Linear functions have a constant rate of change, either increase or decrease. In this particular case, we're talking about increasing since we're talking about salaries. Okay, so with that information and with that concept now in your head, let's see if you can go back and answer correctly the question on your Google form.